A fragrant ornamental grass to some, while an olfactory nuisance to others, the prairie dropseed grass dominates the area outside of Armstrong Hall. Redesign the space occupied by the prairie dropseed grass to generate positive environmental impact while improving the quality of life of Purdue students. How do you envision the space?
Our goal is to redesign the space occupied by the prairie dropseed grass outside the Neil Armstrong Hall of Engineering,
in order to generate a more positive environmental impact and a renewable energy source that will be measured in joules, while reducing the number of plant odor complaints from students by 100% within an 8-week period. Some of the rationale for our problem is that the grass doesn't smell good and it's not aesthetically pleasing.
The following is a list of criteria.
Produces at least 3 times 10 to the 10 joules of energy, which is equal to 14,000 kilowatt hours per year for the Neil Armstrong Hall of Engineering.
Area must include oxygen-producing and carbon dioxide-absorbing trees, flowers, or shrubs that require relatively low maintenance.
Area must include an object that students can use that is made from recycled material.
Current prairie dropseed grass odor is completely eliminated.
Area provides at least 64 square feet of relaxing seating space for students, faculty, residents, and visitors.
The following is a list of constraints.
Solution cost, including implementation, must be less than $100,000.
Solution physical prototype must cost less than $20.
Solution must be smaller than 2,500 square feet.
The solution must be no larger than 15 feet tall.
We chose to include a solar panel as well as the park area. The solar panels generate electricity, and that can be put toward the electricity grid of Armstrong Hall.
Along the north side of Armstrong, where it is partially shaded, we decided to include the park area, which will include flowers, benches, trees.
In our solution, we combined what would be believed to be the best quality from our best solutions in order to create the most sustainable solution while improving the quality of life at Purdue. And we have the survey data to prove it. We're here outside of Armstrong asking students whether or not they think solar panels would be aesthetically pleasing in this grassy area.
Yes, I would.
Probably, yeah, it'd look better than that.
Your aesthetics? Yeah. As long as you don't block the window, yeah, I can see it.
Now we're asking students whether or not they think that trees, flowers, and benches would look better than the grass here now.
Yeah, absolutely.
Yes.
Yeah. Sure, why not?
Yeah.
Yeah.
Our final solution is to include solar panels, crown imperial flowers, eastern redbud trees, and recycled picnic tables.
As our research data shows, our solution is clearly superior. Now that we have explained the unique features and strengths, we will explain the math and functional model
For our solar panels. We'll take the total area of dropseed grass outside of Armstrong Hall, subtract the area on the northwest corner from the total area of Armstrong dropseed, then convert into square meters, then determine the number of solar panels that will fit within the given area, determine the cost of each solar panel and the total cost of the solar panels, and then consider implementation costs and calculate the final cost for our solar panels. For the second part of our mathematical model, we're going to take the area of redesigned space available for solar panel usage and multiply by the average number of watts of energy per solar panel to find the total energy output in watts. Then we're going to multiply by the hours of energy output by solar panel system on a daily average to find the amount of energy produced yearly by solar panel system, and then we will convert this amount of energy into joules.
So our final design is very innovative. It's novel because it'll be one of the first places on campus to have large visible solar panels to display Purdue's drive to become a self-sustaining campus. Desirable as shown by our surveys, feasible as shown by our mathematical model, and viable due to its sustainable nature and its ability to produce electricity.
The most innovative feature of our solution is the addition of the solar panels.
The limitations of our solution are in direct connection to the solar panels. We will obviously not produce enough energy to power the entire Neil Armstrong Hall of Engineering. The flowers and trees will be out of bloom, affecting the oxygen production. Listed are the constraints and criteria and how each is met. Through our design process, we encountered many problems, yet we overcame the challenges, and we are very proud of the solution we created.